Hi, this is Mike Shore, and this is another tutorial working with solving problems. We're going to look at using the IPO approach, our input, processing, output approach, to go from a word problem to a working C++ code application. So we're going to start off by looking at the basic problem, exercise in Chapter 4, number 11, on page 108 of our textbook. And the problem statement is, A1 Appliances needs a program that allows store clerks to enter the number of dishwashers in stock at the beginning of the month, and the number purchased by the store during the month, and the number sold to customers during the month. Obviously a very simple problem, but the problem basically needs to calculate and display the number of dishwashers in stock at the end of the month. So if we look at that, and tear it apart, tear the word problem apart, based on our input, processing, output structure, we can look at the items I've highlighted in red on this slide and notice that we have three inputs. We need dishwashers in stock at the beginning of the month. We need the number purchased by the store during the month and the number sold to customers. And as an output, we just simply need the number of dishwashers in stock at the end of the month, and that's the green last sentence. If we look at this from our IPO perspective, what I've done here is break it down to the items that we need. For our IPO, we have the input, which is our beginning stock, the number purchased, and the number sold. We don't have to do any processing with this particular problem. And as output, we just need the end stock at the end of the month. If we break that down to code, we need to start looking at the issue of creating variables so that our C++ code has something to work with. The first two items are our beginning stock and the number purchased, which we both are setting to integers because we can't obviously have a part of a dishwasher. And then also the number sold, or all three are integers, or ints. Output, we simply need our integer end stock. And again, we're setting those all to 0. Initializing is often a good thing to do, even if you're not going to use it without putting some sort of value to it. Now we look at the algorithm that we're going to use. And again, the algorithm is nothing more than the step-by-step way in which we're going to solve this problem. If we look at our algorithm, we're going to enter the beginning stock, the number purchased, and the number sold. This input is going to be carried out by the person using our application, most likely the store clerk. If we look at our code on the right-hand side of this slide, you notice that we have the cout, less than, beginning stock. Again, these couts on this particular section of code is nothing more than our way of prompting the user to create some input. So we're asking them to put the beginning stock number into the code, and as cin greater than, we're going to accept that as our beginning stock number from the user. Then we tell the user, prompt them with number purchased, and then as input we're going to set purchase to that value, and then finally the same thing with number sold. Cout number sold, cin sold. If we look at our algorithm again, we're going to calculate the ending stock simply by adding the number purchased to the beginning stock and then subtracting the number we've sold to our customers. So that is simply equated as end stock equals begin stock plus purchased minus sold. That's pretty straightforward, I think. Finally, we need to display the ending stock. And as usual, everything that we're going to do in this particular application is cin, cout as far as our interaction with the user. So we're going to do a cout, ending stock, end stock, end L. Remember, end L just automatically creates a new line on our output screen in our console. And that's it. That's all the code we need to solve this problem. So now our next step is to move on to Visual Studio.